To make our new photo view in the My World app, we're going to use objects from the main view. When people talk about object-oriented programming, they tend to talk about two things. The first is all that cool encapsulation and polymorphism stuff, which makes it easy to modify programs. And then they talk about reuse, that you can create reusable objects that save time and money. When you enhance or extend your program, what you're doing is reusing the existing code to create essentially a new program. You know, the best models for reusability are found in the frameworks that you use to develop apps. You reuse the frameworks by adding your own app functionality to a framework that already includes the code for stuff like displaying windows and controls and menus. In other words, a framework provides most of the user interface and you just add your code to do specific things with it. Well, what makes this scenario work is the fact that with object-oriented programming, you can essentially copy all the characteristics of an existing class to make a new class. And the new class inherits the methods and data structure of the existing class. So now what we want to do is enhance the My World app to show photos or images from the photo library on the user's iPhone. We've already created instances of the same object, the main view controller, along with inherited methods of a superclass to implement a second view, which is the photo view controller. That view is going to show a flowing image, and the user is going to switch from the main view to the second view with a horizontal scroll. Now, it's going to be easy to do this because we've encapsulated the details of how to set the falling words for the first view, the main view, and how to set the falling image for the second view, or photo view. We've already encapsulated the details of how to save preferences, how to show info from the main screen to select new preferences. So it should be a piece of cake to add the ability to display photos. The programming style of Objective-C is to create objects that encapsulate the details of how they work. Using encapsulation enables you to safely tuck data behind an object's walls. You can keep the data safe, reduce the dependencies of other parts of your program on what the data is and how it's structured. Encapsulation is also useful when you apply it to app functionality, as we're going to do. When you limit what your objects know about other objects in your app, changing the objects or their functionality becomes much easier because it reduces the impact of those changes on the rest of the app. And with inheritance, you can do a number of things that make your programs more extensible. As we're going to do in a subclass, Photo View Controller, we can add new methods and instance variables to what is inherited from the superclass. And we can refine or extend the behavior of an inherited method and change the behavior of an inherited method. And combining inheritance and encapsulation gives you polymorphism, which is the ability to use objects that do the same thing in different ways. In our case, the main view controller does one thing with words, and the photo view controller will do something else with images. But they'll both do it in the same way, responding to the same messages from the other objects. Now let's look at how far we've come in the design of our app. As you recall, the main loop starts everything going with UI application main, which sends the message application did finish launching with options. The message is sent at the very beginning, before the user can even see anything on the screen. So here's where we already inserted our code to initialize main view controller and photo view controller. We also covered the back end of the process down below, when the app moves to the background. The application did enter background message tells the delegate that the app is now in the background. Now we would normally use the application did enter background method to release shared resources, to save user data, to invalidate timers, and to store enough information to be able to restore the app to its current state later when it comes into the foreground again. And we're going to actually do that to invalidate our timers. The application did become active message tells the delegate that the app has become active, and either the user launched the app or switched to the app after using another app. And could have also just ignored an interruption, such as an incoming phone call. In any case, the application did become active message starts everything again back at the top as if the user had just tapped the app icon. And we would normally use the application did become active method to restart any tasks that were paused, and to refresh the app's user interface. Now it's the part in the middle, the event loop, that we are still focused on. The event we want to handle is the user scrolling the view. And we just recently used the UI scroll view class to add horizontal scrolling. The methods declared by the UI scroll view delegate protocol allow our adopting delegate to respond to messages from the UI scroll view class. And the UI scroll view class provides support for displaying content that's larger than the size of the app's window, so users can swipe to scroll within that content. So now comes the easy part, creating the photo view that the user swipes to from the main view. This photo view will display a flowing image in the same way that the main view displays flowing words, but with a few minor adjustments. So we need not just a new view, but we also need a light info button in the view. Remember the light info button? It's right here in the main view nib file in the My World app. And as you can see in the Connections Inspector, its action, touch up inside, connects to the show info method in the file's owner. And who, of course, is the file's owner? We can find that out by clicking the file's owner here, checking the identity inspector, and its main view controller. Okay, so we know what this is, and we're ready to use some of its objects. This main view already has a view object here, and we can open this doc to show it in more detail, and we can click the disclosure triangle to see what this view contains. We see it contains the image view background, and it contains the light info button. We can see its attributes by looking at the Attributes Inspector, the Info Light Type button. So we've already selected the main view nib file, so I'm going to select the view, and we're going to copy this view object, which includes the image view and the button, to our new nib file photo view down here. So we selected view, and we choose Edit, Copy. Very simple. And we want to copy this object to the photo view nib file. Photo view nib file already has a view, but there's nothing in it. So what we're going to do is we're going to choose Edit, Delete, and delete this view. And then we're going to choose Edit, Paste, and paste the view from mainview.xib right here into photoview.xib. When we open this up by clicking the disclosure triangle, we see we have the image view, which you can see, and we also have the light info button, which is there. As a result, we automatically get the view. And if we open the disclosure triangle, we see that we automatically get with it the image view and the light info button. We can check its attributes in the Attributes Inspector. We can change some of the attributes if we wish. But as you can see, the light info button looks pretty good the way it is. It's exactly the same as it looks in the main view. Now we're going to leave this XIB file for now with its view, but we have to realize that we still need to come back to it to connect the view and its button using the Connections Inspector. We're going to have to connect them to the appropriate methods. Well, we want to make sure those methods are properly coded first.